Welcome. This video introduces natural response for RC circuits, a capacitor and resistor in parallel. For the RC circuit shown in the schematic, the graph of V of t and the equation for V of t are the natural response. Natural response circuit analysis only reflects the nature of the circuit itself, rather than any current or voltage source driving the circuit.
That is why we call it natural response.
Natural response is also called zero input response, ZIR. Zero input response means that there is no current or voltage source driving the circuit when analyzing natural response. The natural response of a circuit comes from initial conditions, voltages or currents, that are already in the circuit when the analysis begins. Zero input response starts with a voltage across the capacitor. This starting capacitor voltage, V sub C0, is called an initial condition. When the natural response analysis begins, the voltage across the capacitor, which started at V sub C0, becomes the time-varying voltage V of t, which decays exponentially down to zero, according to the equation shown for V of t.
Natural response of a first-order circuit, like this RC circuit, is an exponential function f of t, whose equation and graph are shown here. The horizontal timescale can be marked in terms of the time constant tau. When t equals tau, e to the minus 1 equals 0.36. Comparing the two exponential function equations, we see that for this RC natural response, tau equals RC.
The establishment of initial conditions is often modeled with ideal switches in circuits. These circuits here use single-pole, double-throw switches. The circuit on the left is series RC, and the circuit on the right is parallel RC. Current can charge the capacitors. Current flows in the series RC circuit as long as the source voltage, V sub S, is higher than the capacitor voltage. When the capacitor charges up, current stops flowing and the initial condition, capacitor voltage, V sub C0, is established. Current flows in the parallel RC circuit continuously through the resistor. Current also flows into the capacitor until the capacitor voltage equals the current, I sub S, times the resistance R, which establishes the initial condition. When the switches are moved to the lower positions, the sources are removed from the circuit and the natural response analysis begins. At this point, the voltage V sub C0 becomes the time-varying voltage V of t, decaying exponentially down to zero. The counterclockwise current is the resistor current I sub R of t.
For more detail on the current, please view our video on RC reference polarity.
When the sources are removed, the series RC circuit now has the same topology as the parallel RC. They are now both parallel RC.
If the initial conditions for a natural response analysis are already there in the circuit, how do those initial conditions get there? What practical electrical situations might correspond to the switched circuits before the switches were thrown, that is, before the analysis starts?
The zero input response initial conditions for practical circuit examples can come from some voltage or current input signal that happened before the time frame of the natural response analysis. Natural response is a mathematical and academic construction which can be applied to different places and times within other behaviors in a circuit. Let's look at a specific example. This RC circuit has a voltage source that supplies 1 volt DC for 5 microseconds. This voltage charges the capacitor to 1 volt, the same voltage as the source. That is, Vc equals Vin. At 5 microseconds, the input voltage Vin goes to 0, leaving 1 volt on the capacitor. The voltage source at 0 is now effectively a short circuit. Starting after 5 microseconds, the capacitor voltage drains away as current through the resistor. The time period, starting at 5 microseconds, can be analyzed and understood in terms of natural response, where the 1 volt voltage on the capacitor is the initial condition at 5 microseconds. One final note: natural response is one of several types of response in circuit theory. Step response is another common response in circuit theory. Step response and natural response can go together.
Thank you for watching and learning with us.